Hello, everyone. Welcome to today's webcast, How Solidworks Cam is a Game Changer with Integrated CAD and CAM. I'm the moderator, Krista Prokos. Before we get started, I want to let you know that you can submit questions for today's presenter by typing them into the Q&A panel at any time. We'll collect them and address them at the end of the presentation. And now I'd like to introduce our presenter. We're happy to have with us today Jeff Reiser. Jeff is an application engineer at Fisher Unitech and a CAM expert. Jeff, take it away.
Good morning, everybody, and thank you for joining our webcast today on how SolidWorks Cam is a game changer with integrated CAD and CAM. Just a quick background on myself before we get started. As Krista said, I am an application engineer for Fisher Unitech. I am the AE specialist for the CAM product, and that includes the SolidWorks Cam as well as CamWorks. My background is 17 years in the CAM industry, working with various products, SolidWorks Cam, CamWorks, as well as MasterCam. And I am also a SolidWorks Cam, CamWorks, and MasterCam certified support application engineer. Today we're going to be taking a look at the SolidWorks Cam product and how it is integrated into the SolidWorks product. And we're going to do a quick demonstration showing the two different modules that SolidWorks has come up with, and we're going to look at SolidWorks Cam Standard, and we're going to look at a live demo of the SolidWorks Cam Pro product. And as we go through these demonstrations, I'm going to be pointing out to you which capabilities exist within which modules of the SolidWorks Cam product. And then at the end, we're going to follow that up with a Q&A. So as Krista said, any questions that you have, please feel free to submit them, and we will answer them at the end of the presentation. All right, so now I'm going to kick into a live demonstration. And the first thing we're going to look at, so a lot of you might know this, and some of you might not be aware. When SolidWorks 2018 was released back in October, I believe, it now has embedded CAM capabilities. And what happened was SolidWorks formed a licensing agreement with CamWorks, and SolidWorks took ownership of some of the base packages that CamWorks had. And this was an easy transition for them because the the CamWorks product was never really designed to run in any other interface than the SolidWorks interface. So as we go through this, what we're going to be looking at, so the product is broken out into two modules. All right, there's a SolidWorks Cam Standard module. And the one thing to know with that module is anybody that's currently running SolidWorks 2018 on maintenance has those capabilities already. They come with the SolidWorks 2018 install. So if you guys are running 2018 and you're on maintenance, you guys already have existing CAM capabilities within that software. And then we're also going to look at the second half of the demonstration is we're going to look at the SolidWorks Cam Pro. All right, so like any other product within the SolidWorks interface, the SolidWorks Cam runs as an add-in. So if we come down here and we look at our add-ins, you're going to see down here at the bottom, I am running the SolidWorks Cam, and we can check these on to either fire up every time we fire up SolidWorks, or we can toggle them on and off at any given point as we're working inside the SolidWorks interface. The one thing I will stress is what we've seen is some people are running SolidWorks 2018 and they're not able to see the SolidWorks Cam add-in. You have to make sure that when you do the SolidWorks 2018 upgrade or when you go to do the install, that you actually select it as a product to be installed. If you do not select it, then it will not install. So if you're running 2018 and you don't see it in there, that's most likely what happened. All right, so you guys, on my screen, I have just a basic part, a lot of prismatic features, and that's really when we're working within the SolidWorks Cam Standard, the capabilities that exist there are going to be mostly your 2.5 axis machining. So anything from contouring, pocketing, facing, drilling, tapping, and, you know, all those basic 2.5 axis functions are included with SOLIDWORks 2018. SOLIDWORks CAM is, I want to say it's primarily a feature-based system. And what that means is we can recognize features and we apply strategies and toolpaths based off those features. When we talk about CAM, there's really two platforms that we can run on. We can run in a feature-based environment, or we can run in an operation-based environment. And the problem with the operation-based environment is the programming time is extended because of the amount of work that has to go into generating a toolpath. Meaning I have to pick a piece of geometry, pick a toolpath, select a tool, and then go in and set all my parameters to get that toolpath to process. With a feature-based system, we automate a lot of that, and that's what you're going to see. So the first thing that I'm going to do here is, if you take a look up here in our command manager, we really have minimal impact on the SOLIDWORks interface. You'll see us up here in the command manager. We have a SOLIDWORks Cam tab here. And then if you come down here where the SOLIDWORks feature tree sits, you'll see we have a SOLIDWORks Cam feature tree, and then we have a SOLIDWORks Cam operation tree. And then we also have a tool crib tree here as well, so you can see the tools in your active tool crib. All right, so what I'm going to do is I'm going to go up here and I'm going to click on my machine, and I'm going to tell it first what type of machine is this going on. So I'm going to go ahead and select mill, and then we're going to go to the post processor page, and I'm just going to make sure that I got the correct post processor that I want loaded up. All right, stock manager, by default, we're always looking at the model. All right, so at any step of our programming process, we're always looking at stock. So by default, no matter what, it's always going to generate a bounding box, which is going to give me the minimum amount of material needed to cut this part. Now we can adjust that if needed by simply going in here and expanding that, or adjusting it, to whatever size, length, height, whatever, to match the stock that we're actually cutting. Now, if we don't want to use that bounding box, we have various other options to set stock up. And this is where really being integrated in SOLIDWORks can help us, because we can use SOLIDWORks Sketches. So if I have a sketch defined, if I'm using a cast, or, I don't necessarily have a square or rectangle shaped stock, we can identify that with a sketch. We can use an STL file. So if we have in-process work where applications have already been, machined or completed, or other operations have been done on that part, and I want to load the in-process stock. And then one of my favorites is being able to use a part file, and this allows us to use maybe another configuration of that part. So if I have multiple configurations laid out within that part file, I could actually select another configuration to use as my stock for the current part that I'm cutting. All right, so what I'm going to do, I got my machine set, I got the stock set, so I'm going to come up here to my setup. I'm going to go to my mill setup, and I'm simply going to come down here and I'm going to check the top of this workpiece. And all this is basically doing is telling it orientation of the workpiece in the machine, direction that tool's coming perpendicular to the workpiece. All right, for my origin, I have defined, I'm going to use this coordinate system. And again, this is one of the benefits of being integrated within the SOLIDWORks environment, is that coordinate system that I use is actually a SOLIDWORks function. By using that, it's an interactive nomen, so I can use it for various things throughout my programming process, other than just defining my origin. All right, so if we look up here, you're going to see extract machinable features. And what this does is this utilizes what we call AFR, automatic feature recognition. And what this is going to do, when I select this, it's going to go through the model, it's going to scan that model, and it's going to start extracting features for me to cut. Now you'll see here there's two boxes grayed out right to the right of it. One's a generate operation plan, and one's a generate toolpath. This is a three-step process. So once I extract machinable features, it analyzes the model, and you're going to see under my mill part setup that I created that it generated a bunch of features. Now the one thing that I really want to point out and that I want to stress to everyone on this webcast is this does not have to be a native SOLIDWORks file. This part happens to be a native SOLIDWORks file. So when I go to the SOLIDWORks feature tree, you're going to see that I have history here. You can see my holes, my extrudes, my cuts. But we are not using that information. When we run the automatic feature recognition, we are extracting our own features to apply toolpaths to. So if anyone out there is getting parts in from the outside, maybe they're not always native SolidWorks files. Maybe they're other, whatever CAD tool that the individuals are using that are sending you files, we can still work with them. Even if you don't want to run feature works on it in SolidWorks, we don't need those features. All right. So under the mill setup, you'll see all the features. You're going to see that they're blue, which means all it did was identify the features. As I hover over them, you can see it highlights the features, but there's really nothing there. There's no toolpath data. There's no tool motion or anything like that. So the next step in the process, once I extract machinable features, you're going to see now the generate operation plan has become active. So I'm going to go ahead and select Generate Operation Plan. And what you didn't notice, you may have, but you probably didn't, is it kicked me from the SolidWorks Cam feature tree over to the SolidWorks Cam operation tree. And now you'll see I have a list of operations here that have been applied back to the features. When we look at these operations, they're blue. And when I hover over them, you'll see it still looks like it did when I was hovering over the features that it established. So there's still no toolpath data. All it did was apply strategies to those features. All right. Now you'll notice once I generate the operation plan, the Generate Toolpath tab is now active. So I'm going to go ahead and tell it to generate toolpath. Once I generate that toolpath, now you'll see these turn from blue to black, which means toolpath data has been generated. So as I hover over these, you'll see that actual toolpath motion has been created. And now we are ready to go ahead and see what this part's going to look like once we put it on the machine. Now, when we talk about feature-based systems and we talk about operation-based systems, the one thing that tends to happen with certain CAD or CAM packages is a lot of feature-based systems tend to sacrifice a lot of control of the tool motion, and sometimes it is what it is. We apply a toolpath to that feature, it generates the motion, and we're stuck with whatever motion we get. We give up a lot of control. Well, SolidWorks Cam has done a great job at not only, we have great automatic feature recognition, we are a feature-based system, but when needed, any parts of the tool motion that it generated, if I'm not happy with what it gave me, or if I need to make changes, maybe tooling change, maybe depth cuts need to change, maybe I don't like the lead in, lead out of a cut, we can simply come into the operation, double click it, and now it's going to open up into the actual parameters that are driving that toolpath. So now we are functioning like an operation-based system. So working within the SolidWorks Cam, we're really giving you the best of both worlds. We're giving you the automation of a feature base with the automatic feature recognition, but we're not sacrificing any of the control aspects of the toolpath. We can go in and modify anything that we need to change about this. If I don't like the tool that it gave me, I can simply go into my tool crib, say I want to add a tool, and then I can pull up my tool list and select a different tool, regenerate that tool path, and continue on my way. Now, the one thing I will point out as we're looking at the tool crib here, or the back-end tool database to SolidWorks Cam, there are thousands of tools in here. So any of your generic tooling that you can think of, from end mills, ball nose, bull nose, taps, drills, spot drills, anything that falls within that generic tool list, you'll be able to find in here. And we also support custom tooling as well. So if you have form cutters, feed mills, or anything like that, we can work with those as well. All right, so once we generate the tool paths, we have this to a spot where we think everything looks good. Now what I want to do is I want to come up here and I want to simulate the tool path, and I want to just verify that everything that we just did is going to do what I want it to do. And this is what this is going to do, is this is going to actually show us material removal. So what we see taking place inside the simulator is what we will see taking place inside the machine out on the shop floor. So we can slow this down a little bit, and then I'm just going to go ahead and hit play, and we're going to go ahead and run through this. Now we have different visibility controls, so right now we're just looking at the stock itself. If we want to overlay the workpiece to the stock, we can do that. If we want to shut the stock off and just look at the workpiece, we have that control. We can shut the tool off, and what you're going to see here, if you take a look at this workpiece, you'll see this gouge at the top of this. If we take a look at the workpiece, it's not supposed to be there. So what that does, and this is the whole purpose of the machine simulation or the Toolpath simulator, to show me when things are not going the way that they're supposed to be going. This is collision. It identifies as collision, and now I know that I can go back into my operations and I can say, you know, was it this rough mill? And I go to my holder page, and I know right off the bat it's a protrusion issue. So the tool is sticking out too far from, or the tool's not sticking out far enough from the holder. It's cutting too deep, and my holder is gouging into the workpiece. So I can go in and I can adjust the protrusion length of those toolpaths or of those tools in my database, and then I can save them. And now when I go back in and I run, everything will verify the way that I want it to verify. All right, once we run through the simulator, the next step in the process would be to actually post-process. And when we talk about post-process, what we're doing is generating code that whatever machine we're sending this part or we're going to run this part on, the code has to be in a format that the machine can interpret. Typically a G&M code, but the codes vary depending on the machine that you have and the control that you have. So when I set this up in the beginning, I used the generic 3-axis mill, and then I used the generic 3-axis post-processor. The one thing that I want to make sure I point out, post-processors are very important, and SolidWorks Cam comes with about 50 generic post-processors for you to use right out of the box. And those post-processors span, you know, they cover all of your basic common machines that you find in the shop today. So, you know, any of your generic FANUC controls, Fidal, your Haas, Siemens, Heidenhain, there's generic posts for all those already embedded in the software. So there's most likely a good chance that you'll be able to find a post already set up for your machine in that list. And then there's also about 15, I want to say 35 mill posts and about 15 turn posts. So it's a very extensive list. So I'm going to come up here and I'm going to select post-process, and we're just going to save it. And what this does is this lets me play through, and it's going to run through all operations. It's going to take Toolpath motion and generate into G-code. Now I can scroll through this and I can take a look at it, but we have a much friendlier environment to analyze this code. So if I close this, it's going to open up what we call the NC editor. And what this NC editor does is it breaks down all of our G-code based on the different functionality of those codes. So when we talk about maybe linear moves or rapid moves, you know, linear move is a G1 move. Rapid move would be a G0. It breaks them down so you can easily tell, okay, when I'm looking at green, I can tell that that's going to be a linear, that's a G1 move, or a G2 or G3. Anytime I see red, red is going to be typically your safety lines, and it's typically going to be your rapid moves that take place throughout the toolpath. And it just does a good job. It's a much friendlier environment to interpret this code or to modify, edit, make any changes that you need to make. And then this also allows you to set up your transmission. So depending on how you guys are set up in the shop, whether you have a machine set up wirelessly, whether you're posting code using a USB drive, whether you're RS-232. If you're RS-232, you have to set up communications to the machine, and that's what this allows you to do within the editor. You can go to your DNC setup, you can start to define your machines, set your baud rates, all the parameters that need to be set for the PC and the machine to talk to each other, and then you'll be able to directly send code from the workstation to the machine out in the shop, and then start running that code on the machine. All right, we went through the automatic feature recognition, we generated the operation plan, and then we generated Toolpath. A lot of automation took place there. But how does that all happen? How does it know what to apply? How did it come up with these strategies, rough mill tooling? Where did all that information come from? Up here we have what we call a tech database. And this tech database is really the main engine that's driving this entire software package. This software is designed to be completely customized to whatever applications, whatever machining procedures that you have in the shop, tailored specifically to you. The one thing that's interesting about this software is it actually learns how you like to program things as you go. All right, so all these strategies, right now, as I run through these, I'm running a lot of the default strategies that are set in the tech database. But if those strategies don't work for you and you need to make changes, you can come in here and you can set up your own custom strategies. So when you run through the automatic feature recognition, it applies your strategies, it applies your tooling information, everything that's specific to you, so you don't have to go in and make any changes once you run through that automatic feature recognition. And what's nice about it is once I go through and I generate these and I modify them and I fix everything the way that I want and I apply a tooling, now what I can do is I can come back here to the feature that those strategies are applied to, and I can tell it to save the operation plan. And what that does is that takes the toolpaths, the feature, tooling, feed speeds, cut parameters, everything that I've dialed in specific for the part that I'm cutting, and it saves it back to that tech database. Now the next time that I run automatic feature recognition on a part, I can pick my strategy and it will apply everything the way that I want it to apply. So it's completely customizable, and it works with you and learns how you like to program your parts. All right, so everything we've seen to this point is what we would call Solidworks Cam Standard. Everything that you've seen so far is included in Solidworks Cam Standard. So everyone can go back. If you're running Solidworks 2018, you would be capable of doing everything that I've done up to this point. Now, what I want to do here is I'm going to pull up another file, and we're going to take a look at this tombstone that I have set up here. And what the Solidworks Cam Pro module, the benefits and the extended capabilities that you get is the ability to work within an assembly file. With Solidworks Cam Standard, you're going to be a part file only. So you're going to you're going to design a model or import a model, and you're going to work specifically to one model. Solidworks Cam Pro gives you the ability to work within assemblies. It gives you the ability to do 3+2 programming. So any of you out there that are running, tombstones or trunnion machines with rotary and tilt capabilities, you'll be able to do that within the Solidworks Cam Pro module. Now, it's just for the indexing, it's just going to be positioning. Once we lock into position, then we're back to just our 2.5 axis capabilities. It also gives you the ability to work with Solidworks Cam configurations, as well as high-speed machining volume mill, so for 2.5 axis. But one of the major benefits that I see with the Solidworks Cam Pro module is the ability, working within an assembly, we can have multiple bodies, and what you can see here on my screen, I have a tombstone, I have multiple Kurt vices, I have the table identified, and then I also have my parts, my work pieces that are going to be cut. What I want to do here is if I go into my part manager, I'm going to identify what I want to have cut. So I pick the 4 parts, and then up here under the machine, I'm going to go ahead and tell it that we're actually going to be running a 4-axis machine, and we're going to select that. And then for the post processor, I'm going to make sure that we're set to just the generic FANUC 4-axis post. I'm going to toggle over to the rotary. Once we tell it that we're using a 4 or 5-axis machine with a 4 or 5-axis post, we can actually go in here and we can define the rotary and tilt axis. So for the rotary axis, I'm just going to come down here and I'm going to select the center tombstone, and it's very interactive. You'll notice I just went out and I just picked the model. Nothing was prompting me to go out there. It's always interactive between the parameter pages and the actual 3D content that I have in my graphic workspace. So, and then I'm going to tell it that the 0 is going to be this face right here. Tilt axis is not going to be, you'll notice it's disabled here. Nothing is active in here. It's because I only loaded up a 4-axis post, so it's not going to let me define 5th axis parameters if there's not the capability within the machine or the post. All right, we're going to go ahead and green check that. All right, so now when I take a look at this, the benefit of working within the assembly and having all this information in here is when we went in the previous demonstration and we did the machine simulation, we just saw our workpiece. We weren't looking at anything. We didn't see a vise. We didn't see any clamps. We didn't see there's any work holding devices that we were using. It's because I can't have them in there. It's just a part file. I can't have the multiple bodies in there. And for me, being able to have an accurate setup or an accurate simulation, Toolpath simulation, we want to see all the stuff that we have sitting on the machine out on the shop floor. We want to see within our CAM tool, and that gives us the ability to make sure that we're getting accurate Toolpath simulation. We want to make sure that our holders are not running into the vise. They're not hitting, you know, the corners when we're rotating. It's not hitting the end of this piece when it kicks from this piece over to this piece to machine. Without working in an assembly and without being able to interpret those multiple bodies and what is a fixture versus what is a part, we don't get any of that feedback, and we need that information to make sure. It's just another kind of, I call them sanity checks, right? To make sure that, you know, Toolpath simulation looked good, the backplotter and the NC editor looked good. Now I want to make sure, just to triple check myself before I go out there and I smash a tool or scrap a workpiece. So I'm going to go in and I'm going to run automatic feature recognition again on this part. What I want to go up here to the Solidworks Cam options, and I want to go to the mill features, and I want to just show you that automatic feature recognition, when we run that, it's not kind of a end-all, be-all. You don't have to process everything on that workpiece because there's situations that come up where you might not want to cut everything on there. And when we go into the Solidworks Cam options and we look at the mill features, you're going to see down here we have feature types, and I can basically tell it what I want to recognize and what I don't want it to recognize. So I'm just going to turn everything off. We'll do non-holes. So anything that's not a hole, it's going to recognize all of our pockets, and it should cut them. It should extract those features, apply toolpaths and strategies to them. So I'm going to go tell it to run through automatic feature recognition. And this is going to take a little bit to process. There's a lot of information here. There's a lot of bodies. There's a lot of features that it needs to extract from those parts. So it's going to take a second to run through this. And then the other benefit of the SolidWorks Cam Pro, obviously, as I touched on, is the ability to do indexing. This is a prime example of where we need to index. It's just 4th axis. It's not 3 plus 2. It's really 3 plus 1. But within this is not available within the SolidWorks Cam Standard. So any horizontal machining centers out there, any tombstone setups where we need to index around that workpiece, this is going to give us the ability to do that. And you can see as we generate and we look at the different setups, it's applying tool motion around the outside of that workpiece on all 4 components. Now, when we go to simulate Toolpath, what's happening here is it looks just like it did when we were in the SolidWorks Cam Standard environment. All I'm seeing is my workpiece. I'm not seeing any of those other components that I have in there. Well, what we can do is we can come in here, I can go edit definition, go to my fixtures, and then I can just start selecting things that I want to identify as a fixture. I can select devices, I can select the actual tombstone, I can pick this bottom plate, and let's pick the table. And once I identify them, now maybe I don't want to avoid all of them, but I'm going to select them all. And then we're going to go ahead and hit OK. And there's new information being applied to the toolpath, so it has to go back through and it has to run through these and recalculate based on the components that we've added to that. So as this processes, one of the other benefits, the volume mill, and you have the volume mill capabilities within all the 2.5 axis toolpaths, and what that does is that really kicks us into what we call a high-speed machining environment. We used to talk about, I've been doing this for a long time, and 4 or 5 years ago, we used to talk about high-speed machining is the future. Well, the future is here now, and the tooling that's being made, the holders that are being made, machines that are coming out, they're coming out with the ability to utilize the high-speed machining options within the CAM packages, and it's much more efficient tool pathing, much more efficient tool life. You're utilizing the entire tool versus minimal step downs like we used to do in the past, and it's just a much more efficient way to remove material when a lot of material needs to be removed. All right, so now I've added those fixture components, and now when I go into Simulate Toolpath, now you're going to see all the components that I've identified as a fixture will now show up in my simulator. So now when I run through this, if there's any collision that takes place, I'm going to see it, and it's going to let me know that either something happened on indexing or something is hitting somewhere, and now I can identify that problem before it's too late and before that part gets out on the machine. We can let this run through real quick. And now when I post this code out, you'll see there'll be an A90, there'll be an A180, A270, and then an A0, indexing around that workpiece. All right, so just to wrap up kind of everything that we just went over and to kind of summarize it down into a few quick points, all SOLIDWORKS 2018 users currently on subscriptions have SOLIDWORKS Cam Standard. So anything that you've seen in the first demonstration that I did, you guys running SOLIDWORKS 2018 have those capabilities already. So I encourage you, if you're on 2018, go back and start utilizing the software. The SOLIDWORKS Cam Standard capabilities include the 2.5 axis machining, contouring, pocketing, facing, milling, drilling, and tapping. SOLIDWORKS Cam Standard only allows part files only, so an SLD PRT file only. Within the CAM Standard, you get the automatic feature recognition, knowledge-based machining, which is a tech database that we touched on, and then with SOLIDWORKS Cam Pro, the upgrade into the other module gives you the ability to work within the assembly file, part configurations, high-speed volume mill, and 3+2 indexing. Well, that concludes today's presentation.